Dear students, welcome to Maths class. Today we are studying about double integrals over rectangular regions. Integration of functions of two variables. First we may study about the volume under a surface. Given a function f of two variables that is continuous and non-negative on a rectangular or non-rectangular region R in the xy plane. Look at the figure. Then the volume of the solid enclosed between the surface z equal to f of xy and the region R is obtained as follows. Each term f of xk yk delta ak in the sum Sn equal to sigma I equal to 1 to n f of xk yk delta ak is the volume of a vertical rectangular prism that approximates the volume of the portion of the solid that stands directly above the base delta ak. The limit of the sum Sn is defined as the volume of the solid under the surface. That is, volume is given by V equal to limit n tends to infinity sigma I equal to 1 to n f of xk yk delta ak. Equation number 2. Here n tends to plus infinity indicates the process of increasing the number of sub-rectangles of the rectangle enclosing capital R in such a way that both the length and the width of the sub-rectangles approach 0. If the function f of two variables is continuous and has both positive and negative values, then the limit given in the right hand of side to no longer represent the volume between R and the surface z equal to f of xy. It represents the difference of volumes. The volume between R and the portion of the surface that is above the xy minus the volume between R and the portion of the surface below the xy plane. This is the net signed volume between the region capital R and the surface z equal to f of xy. We are lead to the following definition. The double integral of the function f of xy of two variables over a region capital R is defined as the limit of the Riemann sums sigma I equal to 1 to n f of xk yk delta ak and is given by double integral over R f of xy dA, that is equal to limit n tends to infinity sigma I equal to 1 to n f of xk yk delta ak. Volume as double integral. If f is continuous on a region R, then the volume formula can be expressed as V equal to double integral over R f of xy dA. Remark: if f has both positive and negative values on the region R, then a positive value for the double integral of f over R means that there is more volume above R than below. A negative value for the double integral means that there is more volume below than above, and a value of 0 means that the volume above is the same as the volume above. Now we can study about properties of double integrals. Because double integrals are defined as limits, they have the following integral properties. Double integral over Rk f of xy dA is equal to k into double integral over R f of xy dA for any number k. Second property is double integral over R f of xy plus or minus gxy dA equal to double integral over R f of xy dA plus or minus double integral over r gxy dA. And the third property is double integral over r f of xy dA greater than or equal to 0 if f of xy greater than or equal to 0 on r. Double integral r over f of xy dA greater than or equal to double integral r g of xy dA if f of xy greater than or equal to g of xy on r. Another property is double integral over r f of xy dA is equal to double integral over r1 f of xy dA plus double integral over r2 f of xy dA, where r equal to r1 union r2 and r1 intersection r2 equal to 5. Property 5 above is called domain additivity property. We now describe Fubini's theorem for calculating double integrals over rectangular regions. This will be on the next class. Thank you for watching. For more educational videos, please subscribe our channel. If you have any doubt, then please write on the comment box below. Thank you for watching.